supposed to do is determine which one doesn't belong. Raise your hand if you think that A doesn't belong. Why does A not belong?
Because it's really deep. And it's the only one that starts like at 0. It's one of the ones that is like they're all right.
So is what he's saying valid?
No.
Is this line steeper than the other? And is it the only one that starts at 0, 0? Where is 0, 0?
That's the origin.
Good, yes, also known as the origin. So that is a good observation and reason why A doesn't belong. Anyone think that B doesn't belong? Raise your hand. And why, Carter?
Because it's opposite hours from the Y, always from the X.
So we have hours on the y-axis, dollars on the x-axis. For the rest are switched. Any other reasons for B? All right, who thinks C doesn't belong? Kobe, is it? Okay, Kobe, why? Because it is the only one that is dotted versus the others that are all continuous. You guys know what type of graphs these are called other than dotted?
Dot graph.
No. You guys know what the opposite of continuous graphs are?
Yeah. Deacon.
Did I hear it? I don't know.
Deacon.
It also starts with this D. This one? Okay. The word I was looking for is discrete. All right, discrete graphs are dots rather than continuous lines. Lastly, anyone think that D doesn't belong? All right, Michael, why? It's the only one that is decreasing. Any other math words you could use to describe that?
It's extending.
Negative what? Negative what?
No negative, negative going down.
No, there's something else that would go here. Slope. It's the only one with the negative slope. This one is steeper up here, A. Do you know why?
No, wait, because the more hours, the more money.
It's started at 0 hours, it's $0.
Well, I was more looking for the math word.
Oh, it's a positive slope.
It is a positive slope. So are these, though. Why is this one steeper?
It's certain that one.
Well, that's not why. It's because the slope is higher in that one. This is discrete. It's shrinking. Whereas the others would be continuous graphs. Yeah. All right, so good observation. Most of the time when we do a which one doesn't belong, there's a reason for every single one, even if it's not clearly seen. But good. Now that we've covered that, let's go through the goals for today, which is to graph equations into variables. So I can use graphing technology to graph linear equations and identify solutions. That's a big thing we're covering today. Also understanding how the coordinates of the points on the graph are related to the equation. And when given the graph of a linear equation, I can explain the meaning of the points on the graph in terms of the situation it represents. So like the real world application. I'm recording right now. I'll link it in here. Anything else I find useful, I'll link in here. And the puzzle piece will be Unit 2, Lesson 5. I noticed that submissions for the puzzle pieces have been getting like lower. They've been decreasing. I don't know if it's just because you haven't hit submit or you plan to get to it and just haven't yet. But notice that or what I've noticed is that the kids that scored highest on the test also had their practices done. So even if you're thinking like, oh, it's just 10% of my grade, it doesn't affect me that much, it does affect your 80% category. So that's how you're knowing if you're doing it right before you take the test. All right, so be proactive, not reactive. And especially because we are taking a quiz on lessons 1 through 5 on Monday. So definitely make sure you have those 5 practices done so that you have that practice and then you can ask questions before. What else? Usually I don't put missings in until it's been a few days since I assigned it. When I put missings in and you guys like email me, like so that you turn in your missing work, I'm happy for you. I update grades constantly. I don't update grades when you email. Like, I don't drop everything I'm doing and update your grade. So I mean, you don't need to email me unless it's been like longer than 7 days that you turned something in. Because then maybe I missed it or you misinterpreted it or something. But otherwise, I update grades almost every day. At least at the very minimum, I take out those missing flags. So that way it no longer says missing. All right. Just keep that in mind. I just want you to get your practice done, get it done before I put in the missing. So like the day that it was assigned, and you don't even have to worry about the missing slide. But otherwise, I'm probably not gonna include this slide anymore in the slideshow. So if you've been meaning to show me your binder check, I'm not gonna remind you anymore. It's a good chunk of your grade. It's supposed to help boost your grade. If you have a bad grade on it, or if you have it missing, show it to me so that we can get that in. Any questions? Right, and then continue to save the rest of your note sheet. And if you're ever absent, feel free to take your own notes on your own paper, and then save them for your binder. All right. Here's the first activity that we're doing. To get snacks for a class trip, Claire went to the bulk section of the grocery store, where she could buy any quantity of a product and the prices are usually good. Claire purchased some salted almonds at $6 a pound and some dried figs at $9 per pound. She spent $75 before tax. So you guys, on your own first, answer these first two. So if she bought 2 pounds of almonds, how many pounds of figs did she buy? She bought 1 pound of figs, how many pounds of almonds did she buy? Try that first. Go over it in about 2 minutes. What did you get for number 1? Yes, Gavin. Six, yes. Anyone got something different? What about number 2? What did we get? Trenton. 11 pounds of almonds. Anyone get something different? Now to find that, did you make an equation or did you just kind of like problem solve your way through it? So what was the first thing you did in number 1? Where did you, so I know where you got the 75 from. Where did you get the 12 from? So you did 6 times 2, because you got 2 pounds at a rate of 6, so you multiply them together. So that's how you got the 12. And then what's 75 minus 12? And then what did you do? And y by 9? Good, so we're solving for figs. At $9 a pound, we know she spent 63 on just pigs, so divide it out, I get 7. Pig is like some type of plant, type of thing. I don't know if it's a fruit, but it's something you eat that is grown. Is it a fruit?
Yeah.
I don't eat figs. I do like pig noodles, so I guess I got, so I don't eat like. Okay. But yeah, that's how you can problem solve your way through that. For the other one, the 11 pounds, what would you do first? And why 9 times 1? She bought 1 pound of figs at a rate of $9. So find out how much it costs, multiply them together. Then what did you do? Like that. What's 9 minus 75? It's actually negative 66. So really, you should reverse the order of those. But yeah, it should be 75 minus 9. And then you get 66. What do you do with that 66? And why 6? Good. So we want to know how many almonds did she buy? You know, she spent just $6 on almonds. So divide it out. That's how we got the 11 pounds of almonds. Now, this third part we'll do together. It says write an equation that describes the relationship between pounds of figs and pounds of almonds that she bought. All right, see if you can figure it out on your own. Take like 10 seconds and write down the equation for this situation. For this situation, yeah. This is the situation, we're answering number 3, right? Question or answer? Wait. All right, so what do equations have to have? Equal signs. Here's a few tips in case writing equations is hard for you. On one side of the equal sign is usually any what? Like an answer, a grand total. So what's my grand total in here? My grand total, 75. That's usually a good place to start. The other side of the equal sign would be anything that contributes to the grand total. So what contributes to the grand total? And how can I show that relationship between the almonds and the cost? Like, how did we know how much 2 pounds of almonds cost? Multiply them together. So how can I write an equation that can help me solve for any pounds of things? What'd you guys write? Emery?
I did go, software, I'm in people at, they, people at, going out with people, I did, that's what happened with the.
So that's a good start. S would represent pounds of salted almonds. And F would represent pounds of figs. Would that give me the dollar amount that it costs? So what else needs to be in my equation?
We need to.
Okay, so what do I put with the S? because that's what you do. You multiply the pounds of almonds you have times 6. You could have also used A, so there's no, just as long as the variables aren't the same. And then anything else I need to put in here? No. In front of 6. Alright, that's how you would write your equation. So my tip would be underline any numbers. Those are usually part of your equation. Look for the signal word around those numbers. Anytime it's per pound, something like that, every week, each day, per person, what operation? Multiplication. And then any totals like 75 would be next to your equation. So even though most students today have just done this work like off to the side, instead of using the equation, know that these are the same exact steps. Like if I was solving for the pounds of almonds, like in the second one, I would plug in that one where. Into the F, because the one here represents pounds of fig. So then it's 6S plus 9 times 1 for F equals 75. What's the first thing I would do? Multiply, just like you did on your scratch work. What's 9 times 1? 9. And then what was the next thing you did? You subtracted. And when you follow your normal steps for solving equations, that's what you would do here too. You isolate the variable by getting rid of what's farther from it. The 9 would be farther. How can you make the 9 0? Subtract it, whatever you do on one side. Good, that's how you got 6x or 6s equal to 66. And then opposite of multiplying by 6 is dividing by 6. All right, so usually every time I show students how to solve equations, they're like, oh, but Ms. Medina, I have a way that's much easier. I could just do this times this minus that, this divided by this. And I'm like, that's the same exact thing that we're doing here. All right, same exact thing. Whatever works for you, great. But writing equations, like you follow the same process once it's written. Isolate the variable, get rid of what's farther by doing your inverse operation. All right, so now what I'm going to show you is how to use Desmos to find some of these solutions. So open up Desmos if you haven't already. You're also welcome to use your own graphing calculator, but since not everyone has one, I'm going to show you on Desmos since you have access to Desmos on your test. But I still, stop talking while I'm talking. I still encourage you to invest in a graphing calculator because on the ACT Aspire and the ACT, you don't get to use Desmos on those tests. So if you can like YouTube how to use your graphing calculator, it can do the same things that Desmos can. Yeah. Yes. All right, so what we're going to do, well, what I'm going to show you first, and just kind of mirror everything that I'm doing so that you can practice. All right, but I'm going to type in the equation that we came up with for the situation. Notice that nothing comes up and it has that little like error thing. And if you hover over the error thing, it says we only support implicit equations of X and Y. So the calculator doesn't read equations with other variables. It only reads them with X and Y. So decide which one do you want to be X and which one do you want to be Y in this situation. The graph that is also printed on your paper has what as the x-axis? The almonds, right? So X to the left, that's the one that goes from left to right, the x-axis. Y to the sky is the one that goes up and down. So that means that the S I can replace with what? X, because that's what's on my x-axis. And the F I can replace with the Y. And now look, we have a line that is the same as what's printed on our paper. Notice they're only showing you the first quadrant because that's where everything's positive. Question? Does 9 go on forever? Oh, the line, yes. Unless you put constraints on it, then yeah, it goes on forever. But in reality, can I buy like a negative amount of figs? I can. Well, I can't buy a negative amount. You can buy 0 of it, but you can't buy a negative amount of it. So that's why they cut off the graph here. So that's another example of constraints. Like in reality, it can't be negative. So we're just showing you that part. All right, but graphs, once you know how to make the equation and put it into Desmos, can be super helpful. They can tell you solutions. So tell me some points like coordinates. What do coordinates look like? So let's follow these instructions then. Choose any point on the line. Someone tell me a point that is on the line. 5, 4. I heard 7, 6 first. Is that on the line? So Davin, what did you say? 5, 4. Is 5, 4 on the line? Is 5, 5 on the line?
6.5.
Just is it? Look at it. Is 5, 5 on the line?
Yeah.
Yes. Is it option? So 5, 5 is on the line.
3,
3, 8, let's see. Would be up here, so it's not on the line. 8, 3 would be right there. Because how do coordinates, what order are they supposed to be in?
Oh, left, right.
Y to X. Try again.
X,
Y. You have to walk, or what is it, drive before you fly. Right? So this is my X, this is my Y. What did we say the X represents?
6. Wait.
Almond. What did we say the Y represents? So when I'm reading the coordinate 5, 5, that is 5 what? When I'm reading the coordinate 5, 5, what does that tell me? In the real world example. That represents,
And
which represents.
overall,
So I have 5 pounds of almonds. And then I have. What? What is it? And it represents. So I have 5 pounds of fish. All right, so that's how you read it. The other coordinate that we said is on the line, 8, 3. What does that mean? The longer this takes, the less time you have to practice.
What was the question?
So what would the coordinate 8, 3 tell us about the situation? There's 8 pounds of almonds. Good. Oops, I meant to put 8. 8 pounds of almonds, 3 pounds of figs. So in other words, when it's on the line, do they make the equation true?
Yeah.
So any point that is on the line is a nope. The equation is what we entered. Any points that are on the lines, so any values for the variables are not what I'm looking for. They are coordinates, but what are they to the equation? And when we have values for variables, what are they? They are coordinates, but that's not the word I'm looking for. All right, we know they're coordinates. We know that they are values for variables. What are values for variables in an equation called? No. Think about what we did yesterday when we found a value for a variable. What's that called? No, you guys are thinking like everywhere around it. It's very simple. Maybe if I show you the learning target again. So I can use graphing technology to graph linear equations and identify what two equations? Solutions. So solutions are coordinates that are on the line. All right, sorry, you guys are thinking everywhere but the right answer. All right, so coordinates are that are on the line are solutions. So would say, scrolling down, would 10-3 be a solution? All right, is 10-3 on the line? All right, and you can use Desmos to even type that in and it'll plot the point for you. So is 10-3 a solution? No. Is 7-3.5 a solution? That looks like it's on the line, is it? Well, why don't you zoom in and know for sure?
No.
All right, it is not on the line. So that is not a solution. Am I able to have decimals for pounds of something?
Yeah.
Yes. So actually at the store, you put it on a scale and then they charge you for the exact amount that you have. All right. Other approximations. So what this was saying is that 7, 3.5 looks like it's on the line. But when you actually plug it into the equation, so like 7 for the X, 3.5 for the Y. Does that equal 75? No. So that's also another way to check. So really you could solve by hand and use Desmos to verify to see if it is actually a solution to the equation. Earlier we said 5, 5 is a solution. So let's check that. All right, and does it equal 75? Yes, so it is a solution. Same with like 8.3, if you look on the line, or if you want to even type it in, you can easily see if it is a solution or not. So it'd be that black dot that's on the line. You can hover over the line and it'll tell you exactly. So cool stuff there. Questions on using the technology? All right, then let's continue. So would a point on -1,9 be a solution? So would -1,9 be on the line, yes or no? You should be mirroring everything I'm doing on Desmos. All right, it is on the line. If we plug it in, does it give us the value that it's equal to in the equation? It does. But is it a solution in the context of the real world situation? No, because why? You can't have a negative for buying pounds of almonds or whatever it is, buying pounds of figs. So still be able to make those real world connections. So having shown you all that, try this one that's also printed on your paper from start to finish. Feel free to use technology. So for part A, how much will be in the account after 3 weeks? Jorge? 850, and you'll get something different. John? What? Did you get something different than 850?
Nope.
Okay. So then what about for part B? How long will it take before she has 1350?
7 weeks.
7 weeks. Now, if, by the way, did you guys just problem solve through it or did you make an equation?
Problem solved.
Problem solve, anyone make the equation before doing that part? All right, well, just know, I think a great test question would be which equation best matches the situation. And notice what type of graphs have we been looking at today?
Perhaps solution.
Linear equation. So graphs that produce straight lines. Do you know what the formula usually is for those graphs? Maybe from like 8th or 7th grade. Lines that have straight lines are usually in what form? Linear equations have what formula? Maybe if I show you the warm up again. These are all linear equations. What would their equations look like? In what format? Think about what we talked about. You guys knew that this was a negative slope. What equation best matches these lines? All right, maybe we'll revisit it. Part of this was writing the equation. So who has the equation that represents this situation that's listed up here? Michael?
I have 475 plus 125 W.
So that will help us find her goal. To find the answers to the A and B part, let's generalize this a little bit more. What part of this varies? That and what else? So like the 475 is what she starts with no matter what. So 125 is what she deposits into her account every week, no matter what. Isn't the total that's in her account also variable? So a really general equation to help answer the first two parts could be this. 475 plus 125 W equals, and we could put T for total, which is basically any variable that's not W. Now, if I write the equation this way, can you tell me what format linear equations are usually in? Maybe that looks more familiar to you. If we type that into Desmos, does it give us anything? So 475. You should be practicing this too. I'll put in here actually. 475 plus 125 W equals T. Does it give me anything? No. Even if I put it in that other format, it still doesn't give me anything. Because what does Desmos only read? X's and Y's. Now, which one should be X and which one should be Y? It's a 50-50 shot. Just give me something. It's like pulling teeth out. This is why we never have time to practice in class. Yes? W should be X, which means Y should be T. And now I have a straight line. It is, it's not crooked. It's not an S shape. It's not a U shape. It's a straight line. It's a very steep line, but it's still a straight line. And we can still use it to find our solutions. All right, but what I was trying to get you to recognize is what format are linear equations usually in? Now that there's X's and Y's in there, do you recognize it? That's like all they talk about is the concern. Where's my smart children in here? We have quite a few handfuls of smart children in here. What format is this in? When I have a straight line, linear, what's the formula for a linear equation?
Zero. Undefined. Undefined.
Does this say undefined?
No.
What does this look like? What is this 475?
That's what.
That's the money that she started with. Where do your graphs usually start at?
Why?
So y-intercept. What's the code for y-intercept? What letter do you use for y-intercept?
Why?
No, you got a y right here. It's a different letter. Oh, close. Close, and will be something else.
And.
Michael? E. And then, so 125 is M, which stands for no. Y equals mx plus c. That equation. That can usually help you set these up. Usually only the M and the B are replaced with numbers. M stands for slope. Another name for slope is also called rate of change.
Yeah.
So anything in the problem that is like continuously changing at a constant rate, that's why it makes a straight line, would go here and be multiplied by something. So my slope is that. That usually tells me I'm gonna multiply it by something. And then my B is my what? And that's usually what I'm starting with. And isn't she starting with the 475?
Yeah.
All right, so that's usually any sort of starting amount that you have in the problem. So kind of use this format to help set up your equation. Because then when it asks how much will be in the account after 3 weeks, where do I plug that in? The 3, once I have my equation, which is right here. How'd you find 850?
Because I did, 475, and I could betting on these 25 for that.
So you would have had to do it how many times though to find it after 3 weeks?
Like, I think,
No, where am I plugging in the 3, class? Into this equation, where am I plugging it in? For the W. Because 3 weeks, we said W is for the weeks. Where would I plug in the 1350? Is that also referring to weeks?
No.
What's it referring to? The total. So I would plug it in there and then solve for W, which would have given me the 7. Again, you can also put it into Desmos and search for where the X is 3 and the Y is W. You can even type in, so like her goal is to save $7,000. You can type in Y equals, I won't do the 7,000 yet. I'll do the one from the last problem. The 1350. If you zoom out, you can see exactly where Y is 1350. And then you can zoom in, hover over where they intersect, and look at what the X is or the W is. Isn't that the same answer we got? Yes, without necessarily doing the math for it. So you guys using the same method, find when the Y is 7,000, how much it is, how many weeks it takes. Don't yell it out. Don't yell it out. But use technology to find it. Let's see if you learn how to use your Desmos today. So again, type in your equation, make sure it's X's and Y's, so that way the calculator reads it. Since we would plug in the 7,000 for the T, or in other words, where the Y would be, since that's like our total, to do that helps you find it easier. Feel free to zoom in, feel free to hover over it. What's the X at 7,000? So the answer might be in decimal form, 52.2. So that's how long it takes her to reach her goal, 52.2 weeks. But what if your answer choices are in whole numbers? What would be the accurate answer? Would it be 52 or 53? 52. Well, think about it. At 52 weeks, this is how much money she has. Is that enough for her college? No. So even though that would be normal rounding rules, she doesn't actually have the 7,000 yet at 52 weeks. So if it wants a whole number, you would have to then round up. And at 53 weeks, she has now more than enough. Questions on that? All right, sorry it took so long. It took the longest in this class, but it's okay. I think we made some breakthroughs. So work till don't pack up now, just keep working on your puzzle piece. These are our learning targets. So we learned how to use graphing technology. We learned that coordinates are the solutions when they're on the line. And explaining the meaning in terms of the real world.